Hello, so in today's video, we're just going to make a key point really about solutions of equations or points of intersection between two graphs. So yeah, the key point we want to make today is that if you have a graph, for example, this blue line y equals f of x, and this curve y equals g of x, the key point is that if we want to determine the x coordinates of the points of intersection between the two graphs, so yeah, these two graphs, g of x and f of x, then the key point is that these points of intersection, we can find those by setting f of x equal to g of x. And then once we set f of x equal to g of x, we can then solve the equation. And then solving the equation will get us our solutions to these points of intersection. So that's the key point that we want to emphasize here. And the roots that we actually get these 2 points of intersection, points of intersection, will be the solutions to the equation, or the roots to the equation f of x minus g of x equals 0. So yeah, these 2 points here, I mean, you could have a random function like, for example, this. As long as you've got a function f of x take away g of x, y equals that goes through these two x coordinates there on the x-axis, these two roots will actually correspond with the points of intersection, and that's kind of how you can determine these roots. So the point is that if you want to find points of intersection, you just set the functions equal to each other, solve the equation, and then that will be your roots of this f of x minus g of x equation, or also g of x minus f of x equals 0. It's the same. You'll get the same roots. Okay, so let's look at an example. So let's say you've got the curve or the reciprocal function y equals 1 over x minus 1. And let's say you've got the graph y equals minus x plus k. So the question is, find the values of k. And again, I should emphasize k is a real number. So find the values of k such that there are exactly 2 points of intersection between the two graphs. So y equals minus x plus k is going to have a negative gradient, -1 gradient. So it could be something like this, could be something like this, something like this, something like this. So we want to determine the k values, so the y-intercept values, the range of y-intercept values, such that we get 2 points of intersection, basically, so 2 solutions. That's the key with this question here. So let's go ahead and do that. So we're going to set 1 over x minus 1, that should be a 1 there, equal to minus x plus k. So that's the key thing we want to do. So set the two f of x's, the two functions, equal to each other, and then proceed to solve. So if we just multiply both sides by x minus 1, we get 1 equals minus x plus k times by x minus 1. Expand the brackets, we get minus x squared plus x plus kx, and then take away k is equal to 1. And then if we just rearrange this, we'll get x squared minus x minus kx, write this a little bit neater, minus kx, and then plus 1 plus k equals 0. So now we've got a quadratic kind of equation. And again, if I just tidy this up even more by factoring out the x in the two, the second and the third term, we get x squared minus 1 plus k times x plus 1 plus k equals 0. So we want this equation. So the question's asking us what values of k will give us exactly 2 solutions. So we want this equation to have 2 solutions. So we need to use the discriminant. So the discriminant b squared minus 4ac. So if we remember from the video that I did a few weeks back on the discriminant, a quadratic equation will have 2 real solutions when the discriminant b squared minus 4ac is greater than 0. So our b value in this case would be this negative 1 plus k. Our a value in this case would be positive 1, just because of that coefficient there. And our c value would be this 1 plus k there, this constant at the end there. So what we want to check is we want to set this bigger than 0. So b squared would be minus this number squared. So actually, when you do minus 1 squared, you just get 1. So actually, this is just 1 plus k squared. And then minus 4 times a, which is just 1, times by k, which is 1 plus k. If we just simplify this, expanding the brackets, we'll get 1 plus 2k plus k squared. And then expand the brackets here, So minus 4 minus 4k, and this must be greater than 0. So again, we can just tidy this up a little bit even further. And if we do this, I'll just move the writing up here, we will get, so tidying this up a little bit further, we'll then get k squared. So k squared, and then 2k take away 4k, so that's minus 2k. And then 1 take away 4, that's minus 3, is greater than 0. Okay, so then can we factorize this? Yes, we can. So we get k minus 3 times by k plus 1 is greater than 0, because minus 3 plus 1 gives us minus 2k there, that coefficient there. Okay, so then if we sketch the graph, if we do like a sketch to see what our solutions would be, we want this to be greater than 0. Okay, so we have these factors here, which suggest if this is the k-axis there, and this is the y-axis, and this is a graph of y equals k minus 3 times k plus 1, we got a solution there. There's two solutions, so k equals 3 there, and k equals -1 there. So again, it's a quadratic, positive quadratic. So where is this graph bigger than 0? So it's bigger than 0 when k is less than -1, and it's bigger than 0 when k is greater than 3, as we can see here from the graph. So we get two solutions: k is less than -1, k is greater than 3. And so yeah, so the values of x, a set of values of x such that there are 2 points of intersection, will be k is less than, as we just said, less than -1, or k is greater than 3. So those would be the two values in such that we get exactly 2 points of intersection using our discriminant there. So that's just a key point from this video. The points of intersection can be found by setting the functions equal to each other. So for example, these two, and then proceeding to solve the equation. And you can use the discriminant to find a set of k values if necessary, which will satisfy the conditions in your question.